Hello, everyone. This is Gurumurthy Ramachandran. And in this lecture, I'm going to start discussing Bayesian decision analysis. In the first section, I'm just going to talk a little bit, setting the stage for why Bayesian decision analysis might be useful compared to the traditional way of making decisions and doing exposure statistics. So just to recap a few things, if you remember, what is the goal for industrial hygiene effectiveness? The goal is essentially that we need to ensure that no worker under our care has unacceptable exposures, but we recognize that we need to achieve this goal even though 90% or greater of exposure assessments are conducted without the use of personal exposure measurements. So there is a lot of subjectivity and professional judgment that enters into this way of assessing exposures and in meeting our effectiveness goal. And we have been using the AIHA exposure assessment strategy to achieve this goal and to do our exposure assessments. And in this AIHA exposure assessment strategy, the goal is to first of all estimate the 95th percentile of the exposure distribution for a similarly exposed group of workers, and then assess which of the following exposure bands does the 95th percentile lie in. And so if the 95th percentile is less than 10% of the occupational exposure limit, then we call that a highly controlled scenario or highly controlled exposure band. If the 95th percentile is between 10 and 50% of the OEL, then we call that a well-controlled exposure control zone or exposure scenario. If the 95th percentile is between 50 and 100% of the OEL, then we call that nominally controlled or just controlled scenario. And finally, if the 95th percentile exceeds the OEL, we call that a poorly controlled exposure scenario. And so we can determine the 95th percentile using measurements or using small data sets. And we all have learned during the previous lectures how to estimate the 95th percentile. And we have spreadsheets and software that lets us do this. Well, there are several problems with estimating or judging the 95th percentile. The first one is that there are very limited data for many jobs and tasks. And sometimes, frequently, there are no data. And so you have to estimate the 95th percentile using your own professional judgment or using a model. So there's very limited data. So when you have small data sets, there will be a very large statistical confidence intervals around the estimate of the 95th percentile. And then frequently we have censored data. So when data are below the limit of detection or LOD, then again, estimating the 95th percentile becomes problematic. Log data are hard to judge if you're going to use your own professional judgment to eyeball the data, as we have discussed in past lectures. And also, most importantly, it is very difficult to communicate what these large confidence intervals mean. And I'll talk about that a little bit more in the following slides. Let's talk about a scenario where we are interested in ethanol exposures whose OEL is 1,000 parts per million. And we go and make 5 measurements. And so the 5 measurements are shown on this slide. The smallest is 52. The highest value is 700. So all the data are well below the OEL. We can say, okay, is the exposure represented by these samples acceptable? So we can run through our traditional industrial hygiene statistics. And we can say, okay, from these 5 data points, we can calculate the geometric mean and the geometric standard deviation, and then we can calculate a 95th percentile, which turns out to be slightly larger than the OEL. So it's 1,140 parts per million. And the upper tolerance limit for 95% confidence for the 95th percentile is an incredibly large 18,700 parts per million. So you can imagine another scenario where the 95th percentile point estimate is below 1,000 parts per million, but the upper tolerance limit is still in the thousands or tens of thousands of parts per million. And it would be very hard to communicate this to, let's say, your manager and say that, we measured it 5 times and all 5 times the values were well below the exposure limit, but the 95th percentile upper tolerance limit is around 18,000. So it leads to a lack of easy communication using traditional statistics. An alternative way to communicate the same type of information is to express judgments in terms of categorical probabilities. And so, what I'm showing here on the top right hand corner is a decision statistic saying that what is the probability that the 95th percentile is located in one of the four AIHA categories. And in this case, we are saying that there's almost a 70% probability that the 95th percentile is located in the less than 10% of the OEL category 1, somewhere around 15% in category 2, and smaller percentages in categories 3 and 4. The advantage of such a representation is that it can directly lead in a very transparent way to a control action. So the highest probability in this graphic is category 1, almost 70%. And so we can say that in my company, if there's a category 1 exposure, that means that we will provide general hazard communication to the workers. Or if it's a category 2, I will say we will provide chemical specific hazard communication to the workers. If the highest category in terms of probability is category 3, then we might conduct exposure monitoring, exposure surveillance, medical surveillance, look at work practices, and so on. And if the highest category in terms of probability is category 4, then we might put the workers and respirators and engineering controls and look at work practice controls or even a process shutdown. In this particular example on the top right, we are looking at a category 1 exposure, so we will provide general hazard communication. And so this way of representing the results of a statistical analysis can be very useful for decision making about what to do next. So this is an example of a probability chart shown more close-up way. And since there are only 4 possibilities, the probabilities in the 4 categories need to add up to 100%. So that is rule of probability. And in this case, we are saying that category 2, 10 to 50% of the OEL, that has 45% probability, meaning that there is a 45% probability that the 95th percentile is in category 2, or the 95th percentile is between 10 and 50% of the OEL. So that is the way to interpret it. So again, there is a 45% probability that the 95th percentile of the exposure distribution falls between 10 and 50% of the OEL. So that's the way to interpret these kinds of probability charts. So how might Bayesian statistics help? So for the same example that I showed a traditional statistics calculation, imagine if the Bayesian decision analysis, and I'm going to talk about how it's done a little bit later, but imagine that a Bayesian decision analysis produces a chart, a probability chart as shown here. And here we are saying that category 4 has the highest probability of 51.3%. And the other categories have smaller percentages. And so the industrial hygienist needs to take an action that is consistent with a category 4 exposure. So put people in respirators, look at exposure control, other types of exposure control, or maybe even a process shutdown. So Bayesian decision analysis is an adjunct or an alternative to the calculation and interpretation of traditional statistics. And the goal of BDA, or Bayesian decision analysis, is to estimate the probability that the true exposure profile falls into a particular category or exposure rating. And it has a very straightforward interpretation. So the OEL is located such that category 4 exceeds the OEL. The other three categories exceed or do not exceed the OEL. One thing I should clarify here, that the charts that I'm showing, they have added one other category besides the four AIHA categories, which is the lowest category, which is where the 95th percentile is less than 1% of the OEL, or it's a trivial exposure. So we have a category 0, which is less than 1% of the OEL, and then category 1, which is 1 to 10% of the OEL, category 2, which is 10 to 50% of the OEL, then 50 to 100% of the OEL, and then greater than 100% of the OEL. So if your 95th percentile is in categories 0, 1, 2, and 3, you are not really exceeding the OEL. If your 95th percentile is in category 4, then you have exceeded the OEL, and there is a certain percentage of confidence with which we can say that. So this is again the flowchart of the AIHA strategy. And as we have discussed many times in the past, we are going to be using both our professional judgment and models and data to assess the exposure. And so we want to define exposure using all available information. So the information could be qualitative. By qualitative, I mean the sort of checklists that we have talked about in the past that can be used to evaluate qualitative information. It could be mathematical modeling that we have discussed in previous lectures. And finally, it can be used using monitoring data that we have also discussed. So all of these are different tools that can be used to evaluate exposure profiles. So the first time when you go around the AIHA strategy, we typically use qualitative assessments and modeling and maybe even professional judgment to assess exposures. And so your qualitative analysis could result in a decision chart as shown here, where we are saying that the highest probability is in category 2. So it's 50% probability that the exposure 95th percentile is located in category 2. Then we might decide to go and do some monitoring, collect a limited number of exposure data, and lo and behold, the monitoring data suggest that it is also a category 2 exposure. So the monitoring results are in sync with what our qualitative assessment is telling us. So the monitoring data suggests that it's category 2 with about 66% probability in that category. But if we now look at both the charts shown here, let's look at category 4 and how much probability there is in category 4. So if you look at the qualitative assessment, it says there's 5% probability that it could be category 4. And if you reflect back to what we had decided at the very beginning, we wanted to say, what is our definition of an acceptable exposure profile? And we had said that the 95th percentile should be less than the exposure limit, and we need to be 95% confident about that. What the top chart is showing us is that we are at the very border of that acceptability criterion. So if you want to be 95% confident that the 95th percentile does not exceed the OEL, then we can have only 5% or less in category 4, and we are exactly at 5%. So we are at the edge of acceptability. Now let's look at the chart from the monitoring results. So the monitoring results, because we probably made very few measurements, it is suggesting that there is almost 11% or 10.9% probability that this could be a category 4 exposure. So this is well above the 5% probability that we can tolerate in category 4. So even though the monitoring data suggests that this is a category 2 exposure, most likely, there is an uncomfortably large probability in category 4. But what Bayesian statistics do is it integrates the results from the qualitative assessment and the monitoring results. And and we'll talk about the Bayes formula later on, but the combination or the integration of the top two charts is shown in the bottom chart. And now this is showing there is an 86.5% probability that it's a category 2 exposure, and there is only 1.4% probability that it could be category 4. So it's a very highly confident category 2 exposure. And so I like to say that industrial hygienists are Bayesian thinkers because, in fact, this is how we go about doing or implementing our AIHA strategy. We start off with initial qualitative assessment, and then we collect some monitoring data and we update our assessment of the exposure. We call it an integrated exposure assessment. And this integrated exposure assessment leads to control recommendations, as I've shown you earlier, that if you're a category 1, you provide general hazard communication and so on down the list. So this is a very transparent way of using professional judgment or using qualitative assessments and models in the top chart. How are we incorporating our modeling results? So that's in the middle chart. And then the integration of these two leading to a clearly defined action plan. So there's a very transparent way of decision making. So the controls that I've shown here, these are just things that I made up, and they look reasonable to me, and probably many companies have some version of this. But companies can also, and institutions can also look at other manuals for guidance about what to do under different exposure decisions. And so there is the ACGIH Industrial Ventilation Manual, there are internal company engineering standards, and there are these things called COSH Essentials Control Sheets. So there are a variety of resources to provide guidance on what controls to implement. The bottom line is that this is a very easy, much easier to communicate way of providing our results and communicating our decisions compared to the traditional statistics.